All right, let's talk about inheritance in class and object-oriented programming. If you need coffee, now is a fine time to keep your camera on and just go grab it really quick. I'm gonna just get set up real quick, and then we're gonna hop into object-oriented programming and Ruby inheritance. Excuse me, where'd you go? Oh, you're behind my Zoom screen, that's why. Okay, I'm on an old branch right now. Let's do git checkout main, git full origin main, git branch dash d class, and git checkout. I always mess this one up. Inheritance. Inheritance? Inheritance. All right. So we talked about classes last week. Let's just take a look at a class in our syllabus real quick and see what's going on with it. In our syllabus, we have a class here called what? Can I get some volunteers? I'm going to need some volunteers just to walk through this whole code set.
We have a class called food order.
Cool. Class called food order has an initialize method that has 3 parameters. When do I call on these 3 arguments? What line of code?
When you're
The second line?
When we use the dot new. The initialize method takes has 3 parameters that it's utilizing, and the dot new is going to pass in those arguments to the initialize method. This is just one of those weird oddities of Ruby. You just have to know that the initialize method and the dot new are connected together. That's it. There's nothing else special about that. The initialize method here in food order is saving 3 special kinds of variables. Can anyone tell me what those special kinds of variables are?
instance variables.
Instance variables. And why do we call them instance variables? Somebody else.
Because they're created when you initialize the new object.
Yep, when we instantiate the new object, they are created and held as values. But what makes them different from other variables? Because all variables are class. Yeah, there you go. They're accessible to the entire instance. So in this case, our instance is called lunch. And so the item 1, 2, and 3 are accessible to the entire instance of lunch versus only being accessible to the initialize method, which would be a locally scoped variable. That's what's going on there. Cool. Adder accessor lets us read and write different variables inside of our class, ones that the class can see, so instance variables. But what's the data type that the adder accessor takes as an argument?
Symbol.
Symbol. Perfect. Good job. Okay. So that's what's going on. There's also one called adder reader and adder writer. Those are available to you to play around with as you desire. I've only found a use for adder reader once in my life. I've never found a use for adder writer personally, but I haven't done a whole lot of deep level like integration with Ruby classes. Cool. There is a term that we have thrown around here at Learn Academy, but we haven't really broken into as a concept. And that term is object-oriented programming. Now, if you remember back to your week 3 assessment, week 3 assessment had object-oriented programming as a looking ahead term. And if we were to look that up, it would probably say something like a programming paradigm paradigm.
PARADIGM.
Thanks. Doesn't need to be capitalized. That revolves around the use of classes and objects. A class is a blueprint or a recipe for an object, and an object is the intersection of data and what?
Behavior.
Good job. Good behavior. So, object-oriented programming is a programming paradigm that revolves around the use of classes and objects, essentially to describe everything. Ruby is an OOP language. It is a strongly object-oriented programming language, and it doesn't really facilitate or support pure functional programming. It does if you tweak it using Lambda functions, but that's about it. So Ruby is OOP. Does anybody else know another OOP language that is strictly OOP?
C+.
Any others?
Python.
C#, I have no idea.
C# has the ability to do more functional stuff, but it mostly utilizes classes and objects. Yeah, so these are examples of OOP languages. Let's see here, what else? Swift, which is what you use for iOS if you're and Apple programming. Yeah, those are just a few off the top of my head. There's tons of object-oriented, I guess, like Java, PHP. So as we learn concepts in object-oriented programming, we learn more about essentially how to work in any of these languages, because the only thing that's genuinely different between these languages just becomes the keywords that are in the language and the syntax in the language. The underlying structure, we're still speaking the same ideas and the same concepts. We're using the same paradigm. So what does that mean? Who here knows a language, another language other than English? Okay, who here knows a language that is based in the same general family as English? That is to say, Latin or Greek. So Spanish, French, Italian. Okay, how much of a different paradigm in thinking is English to those other languages? You can kind of pick it up, right? Sentences are still sentence structures. We still use subjects and predicates and objects as we're talking about in a sentence structure. Who knows a language system that's completely outside of the sphere of English? So any of the Chinese languages, Japanese languages, African languages. Cool. How much of a different thought system is that than English? I.e., when you're speaking it, can you think in English and speak the language? Or do you have to think in that language as well? Anybody want to tell us about that?
Well, I do. But it's totally different. It's not even close. But if you practice enough, I think you could develop
You
a
want to
way.
tell us
Oh.
what language it is and
Oh, I speak Amharic. It is it's from it's the same group as in Semitic language like Arabic, Hebrew, and so on. But ours is just it's just so different. It's I don't know how to explain it, but English is a lot easier than, even though I grew up at home and learning this, I think English is a lot easier for me to learn than my own language.
cool. Anyone else?
Tagalog is somewhat the same. They have nouns, verbs, and adjectives. It's the same structure almost.
Cool. Anybody not like anyone use like speak a language that has like inflections or like where tones are really important? Mandarin, Cantonese.
I speak Cantonese at home, but I'm not fluent, so I always mess up my tones. And then, like, if I say the wrong tone, it's just a completely different word. And since like I'm also not fluent and I haven't like been speaking Cantonese for a while, I think in English and I try to translate that into Cantonese, but it doesn't translate well over.
Yeah.
Yeah, I
Cool.
can relate to that. There's like one word can have three meanings based on how you say it. So that's why what I mean, it's ours is a little bit harder because it's like one word can have like multiple effects, and it was like, oh, I didn't say that, but your tone says so. So you have to be careful.
Cool. Thank you guys. I really appreciate sharing a little bit of that. So the idea here is that while we're in similar language paradigms, it's actually pretty easy to move, and in coding this is more so. It's really easy to move in between languages in similar paradigms. JavaScript to Ruby is actually kind of easy because JavaScript supports OOP, but it's not beholden to OOP. It's called a prototypical language. It's in its own category. So pretty helpful there. Object-oriented programming has something called the 4 pillars of object-oriented programming. And if you end up at a job that is going to talk about, that uses object-oriented programming, you're probably going to be asked about these 4 pillars in an interview. And those 4 pillars are as follows. Encapsulation, inheritance, polymorphism, and abstraction. OOP is such a useful way of thinking about the world. You can actually use it to describe a lot of your interactions in daily life. And you've probably heard me use these terms of encapsulation and abstraction and even inheritance multiple times throughout the cohort, just in plain language. Encapsulation is setting out with a goal that parts of your code need to be private from or scoped outside of other parts of your code. So that's like removing access So we could be using functions, which are encapsulated. Remember, functions, generally speaking, don't call on variables outside of the function. If we can help it, we don't have them do that. Private methods, which will set up private sections outside of classes or inside of classes. We can have utility managers. There are multiple ways to incorporate the concept of encapsulation in OOP. Inheritance, which we're generally talking about today, allows one object to assume all of the attributes and methods of another object. So we can think of me as a human as an object. I inherited the red beard from my family. That's a little bit helpful. It's not quite helpful because my mom didn't have a red beard. My dad also doesn't have a red beard, but I got it from them and not somebody else. Weirdly, the male, never mind. There's a joke there. Charlene gets it.
Was your parents have to have that gene for you to be one?
Yeah, they both had recessive red hair genes. Cool. There's another concept called polymorphism. I have read about 8 articles on polymorphism, and I don't understand it. Not in its entirety. But essentially, polymorphism is the interaction of information occurring in several different forms in several different places in the code set, and it being transformed accordingly. Polymorphism is probably one of the issues that we come across that is like the bugs that we come across as developers. But polymorphism is an expected aspect of OOP. Let's say the condition of occurring more than once. And to abstract something means to hide away implementation or details inside of something else. So these go very deep. I'm going to pause the screen share here for a second and just kind of reorient. PhDs have been written on each of these 4 pillars of OOP, multiple PhDs, deeper than I could ever go. Please do not take what I've just written as the extent of these concepts. They are super deep and you can research till you're dead on these things. Very helpful. Don't necessarily need to go that far. Using them is more important for us as developers, but they are way deeper than the way I'm making them sound right here. Cool? Cool. So there are 4 pillars. These are your basic introduction to them. Okay, so what's a good example of off? Okay, thank you. So with this, classes are made up of 2 pieces of information that we are working with on a regular basis in OOP. Classes are made up of nouns and verbs. Who here grew up during Nickelodeon's era of verb? It's what you do. Really? Just 2 of us? Nobody remembers verb? It's what you do. Okay, 3 of us. Okay. Verbs. What are some examples of verbs?
Run.
Run,
Sing.
sing,
Eat.
eat,
Code.
eat food,
Clap.
clap. Okay, what do we call these when we are making a class?
The actions.
Yeah, so what kind of actions do classes have?
Methods.
Methods, correct. And if verbs are the methods, nouns are
The inputs.
the data. So our classes are containers for data and behavior, and that's those verbs and nouns. So we look back at our classes from last week. We had like our monk. We had a verb, which is our get hair story. We have this method where we can go and get our hair story. But we also had data, which was our name, our hair color, our spirit animal, and our special power, and that kind of stuff. These are all just hair color is a noun, name is a noun, that kind of stuff. So that's a long introduction to inheritance. All right, I have 3 ideas for us to work on over the next 30-ish minutes. I'm down to make class inheritance examples of vehicles. You know I would love. I'm down to make class inheritance examples of food, something kind of like food. We'd have to like find a way of working with that, or of pets. Can I get emoji votes from the cohort on these things? Can I get emojis for vehicles? Oh, I got a pet emoji. I got 1 vehicle, 1 thumbs up. Can I get emojis for pets, for food? 1 heart. 1 hand. Can I get an emoji for pets? 1 pet, 2 pet, 3 pet. Very interactive crew. I think I got 3 for each of them, y'all. What are we gonna do?
I think we have to default to pets.
I think we have to default to pets.
All
All right. So let's make a class of pet real quick. My class of pet is going to describe all possible pets that we could possibly have in our home. Pets come in different shapes and sizes and types, and we're going to get more specific as we go down the list, but we're going to talk about the things, the nouns and the verbs that all pets have. So I want this pet on initialization to whenever I instantiate this pet to have some attributes about it, some nouns that are, I want a couple of them that are static and one of them at least that's dynamic. So here's a good question. Are all pets alive when we bring them home?
Hopefully.
Are all of our pets going to be alive when we bring them home? Okay.
Maybe.
So somebody help me come up with a way to describe the fact that these pets are alive. What do I start? What's the method for instantiating data with a new class?
Initialize.
Yeah. All right. And I want to describe the fact that my pet is alive.
Heartbeat.
Heartbeat doesn't necessarily tell me it's alive.
Should set the
Breathe.
default state to alive.
Breathing.
Is alive true? This is object-oriented programming at its finest right here. Object-oriented programming's job is to define the world around us in ways that the computer can understand. The computer only knows what this is right here. It only knows what this keyword is, what this word is, what these two words are. It doesn't necessarily know what is alive is, but I don't actually need it to know what is alive is, other than that is alive is true. Because that means something to me as the consumer of this data. It doesn't have to mean anything to the computer. Right? Okay, if something is alive at some point, what can happen to it?
It can die.
All right, what are we going to call that?
Is dead.
All right, this is pretty morbid and sad, right? But what have we just created here? What is this thing called?
Method.
A method. And this method describes something to the computer. What does it describe to the computer? As far as the computer is concerned, what does it do?
Saying that is alive is false.
Yeah, it just is assigning the Boolean value of false to is alive. But as a person, what do I know is happening here? There's a whole narrative happening here. I had an alive pet, something happened, now my pet is dead. Sorry to start the morning off on a super morbid note. What else do pets have when we bring them home? Or at least at some point after we bring them home?
Age.
They have an age?
Name.
And is
A name.
age, assuming that we bring them home on day 0, what's their age? Right? Their age has a numerical value and it starts off at the beginning, 0 years old or whatever. 0 days old if we want. Okay, what else do pets have? Don't think too hard about the code here. I want you to actually tell me, like, what qualities do pets have? All pets.
A breed.
Okay, they have a brain, but we don't really need to describe that for anything that we're doing.
Oh, I said, sorry, breed.
A breed? Okay.
Yeah.
There are things that we're going to bring home that don't have breed.
Hair color.
Like alligators don't have breed. Or I guess I'm assuming they don't. They probably do. They don't all have hair. There are Sphinx cats.
But we give them a name.
They do all get a name. All right. And that name, is it the same for every single pet ever? No, it's dynamic. And so what we're going to do is we're going to set up a parameter to call on in our initialize method. Cool. If our age starts at 0 and we have our pet for a while, what happens to that pet eventually?
It grows older.
We can increment our age. All right, anything else that all pets share?
A species.
Okay. And is that gonna be the same for all pets ever?
No.
So what's the species? How do we get that species over to our variable?
Make a species parameter.
Am I spelling species correct here?
That is.
CI or switch.
All right. Can someone give me the narrative of this pet so far? Or a possible narrative of this pet?
The pet was born, it got a name, it was part of this species, it was alive, and then it died.
Yeah. All right. Let's do that in code now. So I need a volunteer. I'm going to use y'all's names as my variable so we can keep track of who volunteered. Is that cool? All right. Can I get a volunteer or voluntold? Cody.
Yeah.
Cody, how do I create a new pet?
We're gonna do Cody equals Cody.new, right?
Okay.
And then with the parameters, they need two of them, which is the name and species.
What's our name?
We'll just name Tank. And it will be a dog. Which is, yeah, dog, we'll go dog.
All right. Let's do Cody. You know what? Let's close out of that, open up a new terminal. Uninitialized constant Cody name error RB45.
Pet.new.
Pet.new.
We're calling on the class, that's right, and we're gonna name the new class me.
We're naming a new object Cody. There is no new class, we're naming a new object. And these are the differences between the actual instantiation of pet. This is gonna be Cody's pet, not just anyone's pet. And it's gonna use all of the values and attributes and methods that our pet had. Cool. Cool. Pet ending in 0DB98 or 0D98 is alive, true, age 0, name Tank, species dog. What? Cody's pet dot growing. Happy birthday to Tank. He Cody. Now I have Cody at age 1. Or a Tank at age 1. Pretty cool, huh? So I know this narrative that Tank had a birthday and is now older. And Facebook even can know that I had a birthday because a certain date went by. But does the program behind Facebook know that I actually had a birthday? Or is it just keeping track of numbers?
It's just keeping track of the numbers.
Right. How we interact with that information, how we display that information gives the illusion of Facebook knowing it's my birthday. But that has no idea. It's just keeping track of 1s and 0s. But this object-oriented programming lets us interact with the real world by declaring things about the real world. Cool. Good job. Let's clear this up. Let's honestly move that. But people have different kinds of pets, and different kinds of pets have different rules about them. So what's a kind of pet that people bring home that maybe has specific rules that are unique to other pets?
An iguana.
Okay. So maybe let's bring that one up a notch. Iguanas share something in common with other kinds of pets. Snakes, frogs.
Reptiles.
They are reptiles. And are all reptiles alive when they come home? Hopefully. Do they get names? Do they have age? Can they have an accident and die? Can they grow up? All right. And do they have their own species? In that case, I don't really want to copy and paste all this code again. I just want to utilize all of this code for my class inheritance. Okay. Class inheritance in Ruby is quite difficult. To make class inheritance in Ruby work, we have to open up settings in VS Code. We go to VS Code, we go to preferences, we go to settings, and then in here we type inherit. No, I'm literally lying. I'll tell all of you. It's just the symbol. That's it. Sorry, that symbol. No, I had it right the first time. Just that. That's it. That's all you got to do.
So what would the other symbol be?
It doesn't work. It tries to compare two numbers. Class reptile inherits from pet. How many of you did I get?
At first I was like, this can't be right, but I was just rolling with it, seeing what happens.
I was writing it down.
I pulled that joke one time. I was only half committed to it, and one person's like, I was so stressed about that moment, I could not handle it. No, it's literally just a little alligator, little angle bracket, that's all. Class reptile inherits from pet. Now class reptile has access to everything that's going on inside of pet. There is one little hiccup, which is how to use the initialize method from pet. We're going to learn that real quick. So in order to use the initialize method from pet, I have to also set up the same initialize method inside of reptile. And then here I pass it the keyword super. Really, essentially speaking, you're always going to use these two things together. You're going to use this little bracket and this super if you have an initialize method. If you don't have an initialize method, you don't need the super. Okay, what arguments did pet get in its initialize method?
The name parameter and species parameter.
Cool. I have to pass these back up to pet through my initialize method. Oh, come back. So let's just call that you can call it X, you can call it hey, you can call it whatever you want. I'm writing it out longhand so that you guys can see who it belongs to. And then I'm passing it up to the parent by passing those parameters into the super. So these come in by calling new on reptile. I hand it off to the super. It passes it up here, and this gets handed off into lines 34 and 35. This is the trickiest part of inheritance. Everything else kind of makes sense. I'm not going to lie. This part is tricky. But really, the key is just making sure that these two have the same order. All right, sorry, my bad. That 56, the super, and 31 here, the parent initialize have the same order. That's important. So I will put that in here. Okay, this seems complicated. I swear to you, the first time you do it wrong, you'll figure out how to do it right and you'll never forget it. It's super easy once you've done it wrong once. Cool? All right, so that's this initialize method. What's something about reptiles that's not true about, say, mammals or other pets that we have? Or even fish? What do we need for reptiles?
Warm-blooded.
Cold-blooded.
Okay, cold-blooded. What else about reptiles?
Different foods.
Okay.
Live food.
Oh, live food. Okay, is that going to be like a data, or is that something we're going to have to do? Feed it live food.
Something we do.
Yeah. Kind of gross. All right, we're going to feed our reptile live food. What happens when we feed our reptile live food?
It stays alive.
Okay. So we don't really have to change anything because we're not updating it to dead.
Goes from hungry to not hungry.
Hungry to not hungry. Okay. And what else should happen when we feed our reptile live food? Should we tell our user that they fed it live food? Or should we take in the kind of food that was fed to it? That might get a little gross. Maybe we skip that part.
Crickets.
Crickets, that doesn't sound so bad. Crickets don't sound so bad. Maybe we'll skip that part. We'll come back to feed what kind of food we're feeding our pets, maybe with a nicer pet.
You could print, say, that name has been fed.
Yeah. Okay, now here's my question. Cody, how are we calling on name when name is not a part of reptile?
You're taking the inheritance from the pet class from above.
Good job. All right, who's got a pet reptile? I'm pretty sure this was Namir's suggestion, right?
It was Elijah, but I'll jump in on it.
Oh, never mind. My bad. Your two
No,
are
it's
right
okay.
next to each other on my screen.
Yeah. So it would be Namir equals reptile dot new. And then you're going to throw up some parentheses, some quotes. The name can be Gene.
Got the build up.
My dad's name, great.
Nice. What was he, an iguana? I think.
He would love to be an iguana. All right.
I mean, then we could either print it or add more.
Let's print Namir and see what we get. So Gene, cold-blooded, and is hungry. How do we know Gene is hungry right now?
Says true.
Says true. Let's feed Gene. Namir, how do I feed Gene?
So we would do Namir got hungry. And then print Namir under that.
Undefined method hungry.
Feed live food.
That's where I was gonna go next.
So now we are looking to do something. So we're calling on our verb. Feeding is our verb. So feed live food. And Gene has been fed. Good job. All right, let's do another one. What's another kind of pet we bring home?
Insect.
Y'all have dogs, y'all have cats, and we're going with insects. Great. Okay, insect is going to have all the attributes of the parent class pet. What do we do?
Less than.
Less than.
Cool. And we need to give pet some info, specifically name and species. How do I set that up? Somebody else who hasn't spoken up yet.
Super.
Okay, and super has to go inside of a specific method.
Yeah.
Initialize.
Yeah. So if super is going to pass up name and species, who's giving name and species to the super?
Pet.
It's handing it off to pet, so it has to come from somewhere else.
The parameters.
Of initialized, right? Oh my gosh, I keep missing my P today. And I'm just going to use the underscore P to represent param here, because we've kind of brought up in multiple ways already, and I'm just trying to draw some differences. So we call name for param for parent. I'm going to call some name P and species P. It's the same data. I'm just using different variables to represent it in different spots. If I have the same data being utilized, but it's being used in different locations, what of the 4 pillars is that?
Is that polymorphism?
Yup. This data is taking on new meanings depending on what class we're calling it inside of. Because a species for a reptile is a different thing than a species for an insect. Okay. Joseph, was this your suggestion, insects?
No.
Nope. Francisco, is this your suggestion?
Yeah.
I have Elijah, Francisco, and Namir all next to Daniel and Lewis. And if Francisco said no, I was going to go to Daniel, then I was going to go to Lewis. All right. Francisco, what do insects have that other pets don't? As a pet, I've never had an insect that's not true. I've had butterflies.
Wings.
I guess they have an exoskeleton.
Okay. What can I do with that info? How can we describe this to our computer?
With the instance variable?
Sure, we can do that. Is exoskeleton going to be true? Is it going to be specific kinds of exoskeletons? What are we talking about here? Do they have multiple exoskeletons?
I think it'd just be true.
Okay.
If it's
And insects do something that reptiles do this, but reptiles will shed their skin, right? I forget what that's called.
Molting.
Molting. Is it still called molting for insects?
No, for reptiles it's shedding and insects it's molting.
Okay. So all right. So molting is a weird one because I'm going to use a verb ing, molting, as in place of a noun, or maybe I should say not molting, but molted. And we'll say false. And if I want to describe the process of molting for my insect, what do we do?
Create a new method. The is molting or is underscore molting.
Is molting always going to be true though? No. Jason's got it right. He's shaking his head no. So what do I want to know about a situation? Oh, I said molting. I want to say molted. So if they have not molted, let's say in a while, they haven't molted in a while, true, molted becomes true. What do we want to say?
That name has molted. That name needs to molt.
There you go. Kind of getting a little complicated now, isn't it? And that's just one variable. We're just checking if molted is false. We're going to set it to true. Tell us, hey, they molted. If it's true, we're going to reset it back to false and say, hey, they're probably going to molt pretty soon. And so we're just setting up a basic conditional inside of our insect class. Should we take a look at that?
Run it.
Okay. I need to volunteer.
To be insect? No thanks.
Joyce.
Okay, so for this we'll do Joyce equals
If you look at my screen, I'll help you out.
insect.new, and then we'll do parentheses. The name is the name is strawberry, and it's it can be a, I don't know what insect molts. Everything? Butterfly? Okay, sure.
I don't even know if butterflies molt.
Tarantula.
We should have done something alongside molting, like cocoon or chrysalis or something like that. or transform. Okay.
And then you,
yeah, let's do it.
yeah, and then we would just do print Joyce dot, oh yeah, print Joyce for that
All right,
one.
let me comment these out so we can actually see yours a little bit easier. Ooh.
Oh, we
All
need another
right.
and.
What did I miss?
Another
The
and.
if
Where?
statement needs an
Yeah,
end.
perfect. All right, let's take a look at this real quick. Joyce's strawberry is alive, true. Species butterfly, exoskeleton, true. Molted equals false. Joyce, let's go through that little molting story.
So if we do Joyce dot is molting.
Ooh, prints twice. Anyone notice why it prints twice? I
You
told
have
it to.
printing up and else, and you have it printing Joyce's molting.
I do exactly. I have a print here on 83 and 86, and I have a print here on 94. So if it activates one of those conditionals, it prints, and it prints because I told it to. So strawberry has molted. Should we check it out? Let's clear it up real quick. Look at this story. Strawberry has molted. Then molted equals true. Strawberry is probably going to molt soon because we've reset it to false. So if we can look at that if we do. Another print of Joyce. Molted equals false. We went molted equals false, molted equals true, molted equals false, and we printed out these strings in the middle. Whole little narrative going on here. Okay, who's tracking? No, wait, better question. Who's tired? Okay, now who's tracking? Who wants to take a crack at this? Should we do one more example? What are some basic things that Pokemon have on start at level 1? Oh yeah, ha.
They get tackle.
That's not how we do that.
Sorry, does it have to be at name?
It does have to be at name.
Does it mirror?
Okay, so we have learn move 1 at name used move at the 0th index. How do we know if this move works or not? Who knows Pokemon? What are the possible outcomes here?
You either, you hit, you're not very effective, you're super effective, or get a critical hit.
Okay, and when we have multiple options, what do we use to describe multiple options?
If else.
If else. And then what are we testing for?
Types.
There you go. And then what are we really testing against?
The other type or the other Pokemon.
We're gonna have to essentially come up with some sort of matrix like tic-tac-toe and work through and loop through that matrix of finding out if our types match up to their types. Does anybody know the matrix of the Pokemon effective types and not effective types?
Yeah.
Yeah, off the top of your head?
Yeah. It depends how many types you want. Do you want all of them or you just want a few of them?
Here's my question, really, and I've never thought of this before ever.
You can also be like quad, and you can be quad time effective or like quad time weak, depending if you are like water, grass, and you go up against like a certain one that is double effective against both. It's a lot.
Okay, generating a Pokemon types table in Python and Ruby. See, there's a problem because there's an actual game called Pokemon Ruby.
Just try Ruby code.
Pokemon database. So this is the chart for Pokemon effectiveness, and
Yep.
somehow we would have to create some conditional statements that map onto this and utilize its effectiveness. Am I going to do that during this lecture? Not on your life. Not going to do that on your lecture. But could we do this if we like something paid us for the next 4 hours to figure this out and write this down in Ruby? Could we pull it off together?
100%.
Yeah, it's just it's an array against an array. Whatever. Cool. Well, our Pokemon can learn moves, and that's honestly, at the end of the day, learning is the goal. All right, can I get a Pokemon, Kelly?
Yes. Pokemon.new. And name. I don't know. We'll name it.
Well, what's the Pokemon name? I guess
Oh,
Pokemon name and species are the same, huh? Kinda.
yeah. I was
Let's
gonna
go with
have to.
your name and then your favorite Pokemon.
I mean, you could have like Pikachu as a mouse species, but
Oh, true. Okay, then Dratini is dragon.
Hell yeah.
and it's a dragon type.
Yes. Or
Actually, I don't know if Dratini
water.
is. Yeah, it is.
Water and dragon?
I don't know actually.
Flying dragon?
Flying.
See, I don't know if it gets flying until it's Dragonite. I don't know.
We're probably
Oh.
gonna have to honestly keep type not just as a string, but as an array. Love using Pokemon in class because it's so thoughtful. So this will be passed in as one item. It'll be passed into type as this type parameter. So that'll work just fine. And then we can iterate through it using our type comparison.
Yeah, it's strictly dragon until it's Dragonite, and then it's dragon flying.
Got it. Okay, so let's keep it as an array though, so we can use it some sort of iteration on it. Okay, and then what was Dratini's species? Is it just dragon?
Yes, I think just dragon.
Is it like Star Dragon or something like that? Like has like something specific?
It just says dragon Pokemon.
All right, cool. If you don't know what we're talking about out here, the greatest like sorry, the largest franchise in human history is Pokemon, if you didn't know that. Larger than Disney, larger than everything else. And it was massive growing
It
up.
says it's an aquatic serpentine dragon.
Hell yeah.
So,
All right, Kelly, what is Dratini learning?
Twister. It learns Twister.
Twister?
Y'all are
Is that no? That's not a move, is it?
That's a
I swear
dragon
to
type
God.
move.
I swear
That it
to
should
God.
not be available, and it can.
We'll teach it Twister then.
Okay, what else do you want to teach it?
I don't think it can learn Hyper Beam at this moment.
I think yours can.
Why not?
Hyper Beam it is.
We got into TM, right, Austin?
All right. Let's take a look at let's see what's going on with Kelly's Pokemon here.
Oh, sorry. On line 109, I think Catherine mentioned it earlier, but move needs to be moves.
Oh, thank you. I was about to run into that problem.
Oh, sorry.
No worries. All right, let's see what happens. All right, let's look at this crazy narrative going on here. Dratini is age 0. Is species aquatic serpentine dragon. Type dragon evolved false level 1. Moves nothing. But then we run through our learn move. And we should probably say something like Dratini learned the move, Twister. Dratini learned the move Hyper Beam. And then when we look at that array, we see Twister and Hyper Beam. This is the most stacked level 1 Dratini that has ever existed in the history of Pokemon.
I raised it well.
Good job. Great work.
On line 118 and 118, 119 now, could we do like dot learn move and then after the parentheses do like dot? Oh, we didn't make a method for it, but like dot. Yeah, we did like to level it up. Because I don't think we made a method for it, did we?
We did not. Should we make one?
I mean, if we have time, why not?
We have 30 seconds.
Yeah, level equals +1. Yeah.
What did we hit? Undefined level up.
That'd be plus equal 1.
No, that should work fine. Oh, for Twister. We're running it on Twister now. Got it. I'm so sorry, Kelly. Dratini lost a fight and is dead.
Painted.
It was only level 2. All right, this is the essence of inheritance. Any questions? Yeah, herd and nurse joy. We should have done is fainted, and it's true.
Austin, I noticed on I think that was line 101.
Okay.
If I'm not mistaken. Yeah, why does those parameters, they don't match exactly? There's 3 on line 100.
Uh-huh.
And then there's not 3 on line 101 by the super.
Great catch. Great catch. So on line 100, I'm not utilizing name or species here in 102 to 105, but I am utilizing type parameter here on 102. And so I have to bring in this type parameter somehow. But I am going to send name and species all the way back up to pet. Pet needs name and species. So I have to bring those in, and then I have to send those back up. And this order has to match the order on 101. It has to match the order on pet. I'm scrolling up to pet now. Pet has them going name and then species. So back in Pokemon, type is just going to be used down here in Pokemon because other pets don't have type. Pokemon have type. And so I can give more values to this initialize for specific child classes that the parents don't need, but I just don't send that up to the parent using the super. Great catch. And if you didn't point that out or somebody didn't point that out, I was going to let you guys figure that one out in the challenges. Good stuff. All right, let's go over the challenges. So we did most of the challenges from last week. We're going to have new partners this week, so make sure you're checking out a new branch. Check out main, then check out a new branch. As a developer, I can make an animal, generic animal class. As a developer, upon initialization, I can give my animal a status of alive, which will be set to true. This is not on instant, it's on initialization. So we have an is alive, true. As a developer, I can give my animal an age of 0 upon creation. So that can be 2 different ways, but I recommend that all animals start off at 0, and that's not dynamic. That's static. All animals start at 0. And then it goes through some things, including using the adder accessor, which we didn't talk about again today, but we did talk about in our classes. I could have used that for any of my classes here. I can go say, now I have the read and write privileges over the evolved variable. Cool, so that's animals. The next one that you're going to do is a fish. Fish is going to be a something that inherits from animal. If animal is a class and fish inherits from animal, what does that make fish?
An animal.
Yeah, child class to animal. We're going to work through these, and then we're going to create a salmon that inherits from fish. So what does that make salmon?
Fish.
A child class for fish.
Yeah, another child class for fish. So it can inherit 2 sets of parents. And then it goes down through these. The key to these challenges is thinking through the difference between a class and an instance. Now, I will tell you something. There is a challenge line in here that generally throws people off because of the way it's worded. And you and your partner have creative responsibility over how you interpret that line. And that's okay. So different groups are going to interpret it differently. Figure out how best works for your code set and move forward. Any questions? All righty. I say we take a 10-minute break. We come back and hop into our pairs.